Today we are going to study Maxwell equations. And first of all, we have Gauss law and electrostatics. And in Gauss law, we know that surface integral of electric field through any surface is given by Q upon epsilon naught, where epsilon naught is the permittivity of free space. And this equation is used for many things. First of all, it explains electric field for any system. Either discrete or continuous. डिस्क्रीट का मतलब होगा जहां पर चार्जेस अलग अलग होते हों, जब हम अलग अलग चार्जेस की बात करेंगे उस सिस्टम के लिए भी एप्लीकेबल होगा। और जहां पर कोई बॉडी हो और उस पर यूनिफॉर्मली चार्ज डिस्ट्रीब्यूटेड हो, we cannot say about the locations of these charges, then we use continuous charge distribution, and this law explains both of these. Second, it tells that charge which is positive emits electric field lines from itself to negative charge. This can be said in other words like this: electric field lines do not form closed curves. And if this equation is written as like this, it means a single charge cannot be exist. But this is not equal to 0, so we can say that a single charge can exist. तो मैक्सवेल फर्स्ट इक्वेशन के अकॉर्डिंग हम बता सकते हैं कि भाई चार्ज कंटिन्यूस और डिस्क्रीट सिस्टम के लिए इस तरह दिया जाएगा इलेक्ट्रिक फील्ड, एंड वो पॉजिटिव चार्ज से नेगेटिव चार्ज की तरफ जाएगा। और इलेक्ट्रिक फील्ड की इक्वेशन अगर हम इस तरह लिखते हैं तो सिंगल चार्ज भी एग्जिस्ट होगा। Now second equation of Maxwell, Gauss law in magnetostatics. Surface integral of magnetic field lines over a surface is 0. It means flux is 0. This can be said by the number of field lines entering is equal to number of field lines leaving. That is why the magnetic flux, this means that this is any surface, and here crosses magnetic field lines. These both lines entering this surface and leaving the same surface. That means that the net magnetic field lines contained by that surface is 0. That is why B dot ds is equal to 0. And in electric field, that is not possible because the charge is contained by that surface. The charge is contained by the surface. Like we can consider a cube, and inside that cube we have a charge that is emitting electric field, and thus we can say that there is a particular electric field passing through that surfaces. और इसका सेकंड एक्सप्लेनेशन होगा there can be no magnetic monopoles because P dot ds is equal to 0. We cannot separate north pole and south pole of any magnet. Maxwell's third equation, this is Faraday's electromagnetic induction. We know that induced EMF can be produced by changing magnetic flux. Now this is EMF, and this can be written as E electric field dl line integral, because we know that E is equal to dV by dr. That is why integration of E dot dr या फिर dl is equal to potential या फिर voltage, and this can be written as d by dt of B dot ds, and this is our third Maxwell equation, which defines whenever there is change in flux, EMF induces, and negative sign shows that it opposes the change. And this can be written like this. Now we have fourth equations, Ampere's Maxwell law. We know that Ampere's law B dot dl, it means line integral of magnetic field gives mu naught times the total current flowing through that length. And this equation, this is Ampere's law, is modified by Maxwell and written something like that: B dot dl is given by mu naught, and the current is replaced by C and ID, where IC is conduction current and ID is displacement current. And this equation is written like this: mu naught ID and this will be something like this. D by dt of rate of change of electric flux, rate of change of electric flux. This equation implies that not only conduction current can produce magnetic fields, but also the displacement currents. When there is conduction current, there can be no displacement current. Either both of them can also be exist at the same time. These both currents, this and this, produces magnetic field. We know that simple current can produce magnetic field by Oersted law, but changing electric field with time can also produce magnetic field. This is the Ampere's Maxwell fourth equation.